What if you traveled faster than light? Einstein said it was impossible. The most fundamental law in physics says nothing can travel faster than light. But what if you could? What if somehow you broke that barrier? What would happen to you, to time, and to the universe itself? The answer involves time travel, paradoxes, and a discovery so bizarre that even Einstein refused to believe it. Why nothing can travel faster than light? Light travels at 299,792 kilometers per second. And according to Einstein's special theory of relativity, this is not just a speed limit. It is a fundamental property of the universe itself. As an object accelerates, it gains mass. The faster it goes, the heavier it becomes. To reach the speed of light, you would need infinite energy. It is physically impossible for anything with mass. What happens as you approach light speed? As you accelerate toward the speed of light, something extraordinary happens. Time slows down for you, relative to everyone else. At 99% the speed of light, 1 year for you would equal 7 years on Earth. At 99.9999%, 1 year for you would equal 707 years on Earth. You would return from a journey to find everyone you knew was dead, and centuries had passed. This is not science fiction. It is a measurable, proven phenomenon called time dilation. What if you could break the barrier? Here's where physics gets truly strange. If you could somehow exceed the speed of light, which Einstein's equations say is impossible, the math produces something terrifying. Time would not just slow down, it would reverse. You would begin traveling backward through time. Every kilometer per hour, faster than light, would push you further into the past. You would arrive at your destination before you left. The grandfather paradox. This creates the most famous paradox in all of physics, the grandfather paradox. If you traveled back in time and prevented your own grandfather from meeting your grandmother, you would never be born. But if you were never born, you could never travel back in time to stop them. The paradox destroys itself. Some physicists believe this proves faster than light travel is truly impossible. The universe protects itself from paradoxes. The Alcubierre warp drive. But here's something remarkable. In 1994, physicist Miguel Alcubierre proposed a method of faster-than-light travel that doesn't technically break Einstein's rules. Instead of moving through space faster than light, you warp space itself. You compress space in front of you and expand it behind you, surfing a wave of warped space-time. The ship itself never exceeds light speed. Space moves around it. NASA has actually researched this concept, quantum entanglement. Quantum entanglement already appears to violate the speed of light. When two entangled particles are separated, even by billions of light years, changing one instantly affects the other. Not after the time it takes light to travel between them. Instantly. Einstein called this spooky action at a distance and refused to believe it. But it has been proven in laboratories. Information appears to travel faster than light, though physicists debate whether it truly does. Tachyons. Some physicists have theorized the existence of particles called tachyons, particles that always travel faster than light and can never slow down to light speed. They would experience time in reverse, aging backward, existing before they were created. No tachyon has ever been detected, but their existence is not forbidden by the laws of physics. It is merely unproven. The speed of light is not just a number. It is the boundary of our reality. It is the wall that separates what we know from what we cannot yet imagine. And while breaking it may be impossible with our current understanding, history has shown that the impossible has a way of becoming inevitable. Subscribe, because next week we push even further beyond the limits of the known universe.